Welcome to section 4. In this section, we're going to talk about how to classify cases with discriminant analysis. In this section, we're going to take a look at the theory behind discriminant analysis. We're also going to go through an example of how to use two-group discriminant analysis to predict the likelihood of purchase. From there, we're going to look through an example of how to use multi-group discriminant analysis to predict risky behavior. From there, we'll talk about discriminant analysis assumptions, and then finally, we're going to compare the results of logistic regression and discriminant analysis. In this video, we're going to focus on understanding discriminant analysis theory. Now, the main purpose of discriminant analysis is that it's going to show the relationship between a group of predictors, these are your independent variables, and a grouping variable, which is going to be your dependent variable, and typically this grouping variable has less than 5 categories. Now, what discriminant analysis is going to do is it's going to show the relationship between these groups of variables by creating a linear combination of predictors that best characterize the differences among the groups in the dependent variable. Now, in practice, discriminant analysis is really used in a lot of the same situations that you would use logistic regression. So it's going to be used often when you're going to have combinations of continuous and categorical predictors and you're trying to predict a categorical dependent variable. In terms of examples of how to use discriminant analysis, you could use discriminant analysis, for example, if you're a bank and you're deciding whether the bank should offer a loan to a new customer. Or you could also use discriminant analysis to determine which customers are likely to buy a company's products. You can also use discriminant analysis when you're classifying students into groups based on their likelihood of success at a school. Or as a final example, you could use discriminant analysis to identify patients who may be at high risk for problems after surgery. Now, in terms of understanding the basics of discriminant analysis, the main idea is that the population of interest, which is your dependent variable, is composed of separate, distinct populations. And these are represented by your grouping variable or your dependent variable. So therefore, you're going to use discriminant analysis in situations where you have a dependent variable that's categorical and it's going to have separate groups. Now, the idea is that each population is going to be measured by a set of variables or your predictors, and that these predictors follow a multivariate normal distribution. So in terms of comparing this to logistic regression, we can already see that we're assuming that we're meeting the assumption of normality, and that's something that logistic regression does not assume. Now, what discriminant analysis is going to do is going to attempt to find the linear combination of predictors that best separates those populations. Now, this is the way that discriminant analysis is going to look. Like I said, it's going to attempt to find the linear combination of predictors that best separates the population. So in this particular example, let's assume that we have two predictors, and we're just going to call them X and Y. They could be whatever it is, that we have an interest in. And let's say that our dependent variable has two groups. Now, what discriminant analysis is going to do is it's going to use this equation that you see here. Notice that that equation is actually very similar to the equation that we would have for either linear regression or logistic regression. And what we're going to do here is that this equation is going to create what we call a function, which is just really a line. And that would be this line right here that you see here, this diagonal line. So what the discriminant function is going to end up doing is it's going to be used so that cases are classified somewhere, or they're giving a score somewhere on this line. Now, what is going to happen is that discriminant analysis is also going to calculate a cutoff. And this cutoff is symbolized by this horizontal line here, the short line here. So if a score ends up being above that cutoff, we're going to say that that case is predicted to be in one group. And if it's below that cutoff, that case is predicted to be in the other group. So that's really what discriminant analysis is going to do. So you can see that, first of all, discriminant analysis is going to have an equation, and that equation is serving to create a score that was going to fall somewhere on that function. You can really think of it as a regression line, but in discriminant analysis, we think of it as a function. We then use a cutoff to determine whether that score is above or below that cutoff, and so that would be basically the category to which that case is predicted to fall into. Now, this has a couple of different implications. The first is that it's very easy when you have a dependent variable with just two categories that you only have one function, okay? But if you have more than two categories of the dependent variable, then you could potentially have more than one function. And we'll talk about that a little later on. What this also means, and this is a little different than logistic regression, whereas we really care about the understanding the effects of the different predictors on a logistic regression equation. For discriminant analysis, is all we really care is where that score falls on the function and whether that score is above or below a particular cutoff. So with discriminant analysis, really understanding is not going to be the most important thing about this model. Instead, it's going to be predictive accuracy. Now, in terms of methods for classifying cases into groups, there are three different ways in which you can classify cases into these different groups. You can classify cases based on the highest probability. You can classify cases based on scores, or you can classify cases based on distance. Now, you can read each one of those right here on this sheet, but when you've met all the assumptions, all three of those methods are going to give you the exact same result. When you don't meet all of the assumptions of discriminant analysis, that's where you end up getting some slight variations. Now, other things to focus on, as I mentioned before, unlike logistic regression, the exact effect of the predictors is not really the main important thing here. Predictive accuracy is what we really care about. Okay, so again, it's important to understand that. Now, in terms of just some additional tips for working with discriminant analysis, many analysts would recommend that you would want to have at least 10 to 20 times as many cases as predictor variable. And again, you're doing this so that you're less likely to capitalize on chance. Another tip is that the number of cases in the smallest group should be at least 5 times the number of predictors. And again, we're just trying to make sure that we have enough cases so that we have a relatively stable solution and we're less likely to capitalize on chance. Another thing that you have to watch out for with discriminant analysis is, check out the outliers, because that could really impact the solution. Aside from checking out the outliers, you can do that by looking at Mahalanobis distance. You can also run the analysis with and without the outliers and see how the results are affected there as well. Now, one thing about discriminant analysis is that multicollinearity is not a problem. Multicollinearity does not affect predictive accuracy. It only affects understanding the effects of each individual predictor. And because that's not the goal of discriminant analysis, we don't really care about multicollinearity. So, when you're trying to decide, do I want to use logistic regression or discriminant analysis, there's a few things to consider. But, if it comes down to multicollinearity, let's say you have it, it's a big problem, but you need to keep those variables in there, then your better option is going to be to use discriminant analysis in that case.